Hey guys, so I wanted to make a video about some stoichiometry frequently asked questions or just stoichiometry problems that I'm seeing commonly. So two of the big questions is how do you know where stuff goes when you set up your equation? And then also how do you know where the numbers go? So how do you know where the units go? How do you know where the numbers go? These are our two big issues that I'm seeing a lot. So for the first one, how do we know where our units go and how to set up our problem is you're always going to go back to thinking about this mole island. And so if you're given grams of something and then you want your answer in grams of whatever the other thing is that you're looking for, you're going to first convert from grams to moles, then to moles of the other thing, and then to grams. So what if you were given moles of the first thing and you want your final answer in grams? Then you would just convert from moles to moles and then to grams. If you were given grams of the first thing but you want the other thing in liters, you have to first convert to moles, then you can convert to moles of the other thing, and then you can convert to liters. So this is a good tool to use so that you can always know what order you're supposed to go in. The biggest thing is to remember that you have to convert to moles in order to change the molecule you're talking about. So if you're starting with water and you're needing to convert to oxygen, you have to go to moles before you can convert from one to the other. So here's a problem that we've looked at before, and it's saying how many grams of hydrogen are necessary to react completely with 50.0 grams of nitrogen. So here we're starting with 50 grams of nitrogen. So we have grams of nitrogen, and we're eventually wanting to get to how many grams of hydrogen. So if we go back and look at our graphic organizer here, it's saying we're starting with grams of nitrogen. So we're starting with a gram, and we're wanting grams of hydrogen. So we're changing to something different. So that means we're over here on the other side, but we're wanting it in grams as well. So that means we have to first convert grams to moles, then we can switch to the other type of moles, and then we can go to grams. Oops, sorry. So we have to go from grams of nitrogen to moles of nitrogen, and then we can convert to moles of hydrogen, and then to grams of hydrogen. And one thing that I've noticed that some of you guys have doing, which I actually didn't notice before, is that you can then just take this pathway and turn it into your equation. So you can just set it up right here so that you know how many steps and your units are actually already in place. So now you just need to go through and put your other units in. This is what we're starting with, so you don't have any units underneath it. But for this next one, we want grams of nitrogen to cancel, so we can just go ahead and put in our grams of nitrogen on the bottom. We want the moles of nitrogen to cancel, so we can put moles of nitrogen on the bottom. And then we want the moles of hydrogen to cancel, so we can write moles of hydrogen over here. So this is a quick way that you can turn that pathway into your equation and where everything is going to go. So notice that I included a label for our mole because sometimes we've been just putting mole, but if you don't specify what the mole is, sometimes it can lead us to getting confused about if it can cancel or not, because you can't cancel a mole of nitrogen with a mole of hydrogen. It can only cancel with the same type of unit. But anyway, so I hope this helps figure out the order that things go in. Our next thing is knowing where the numbers go. So we basically have 4 different types of scenarios when we have our equation. We can have where we have grams of X over moles of X, or the opposite of that, where it's just flipped over. So that would be like here. We have a mole of nitrogen and a gram of nitrogen. Or here we have gram of hydrogen and mole of hydrogen. So that's one of the options we can have. We can also have the same thing but with liters, the same thing but with molecules, and then we can have our moles of X over moles of Y. And that's like here. where we have moles of one thing and moles of something else. So the big thing to notice for these when you're figuring out where to put your numbers in is to remember that if you have the same molecule, so grams of something over moles of the same thing, liters of something over moles of the same thing, molecules and moles of the same thing, every time you have one of these, our mole is always going to be 1. The only time we can put a number with our mole is this example over here when we have 1 mole of something and a different mole of something. That's the only time we're going to have a non-1 number. And when we have this example, this is where we are using our balanced equation. So we'll use our balanced equation for when we have moles of one thing over moles of a different thing. So that would be like this here. We have moles of hydrogen over moles of nitrogen. So this is the only one we can we can have a non-1. So actually let's go ahead and put 1s in place of all of the other moles. So these moles aren't going to get 1s, they're going to use our equation. So we look for nitrogen and it doesn't have a number, so it gets a 1. And moles of hydrogen, we will look for hydrogen, it has a 3, so a 3 goes up here. So we could have a 1, just like we did here, but this is the only time we could maybe not have a 1. So now what is left is to figure out where to put in these other circumstances. So when we have grams, this is where we're using our molar mass, and the molar mass is always going to go on the top with grams. So if you have grams on top, the molar mass number goes on top. If you have grams on bottom, the molar mass number goes on bottom. So that's what number is going to go here. If you have liters, this is where you're using that 22.4. So you would put 22.4 with your liters if it's on top, or 22.4 liters if it's on the bottom. And then if you have molecules, this is where we're using Avogadro's number, where we're using 6.022 times 10 to the 23rd. So that means this number will go with molecules. So if we have molecules on the top, this number will go on top. If we have molecules on bottom, this number will go on bottom. So this is how we're then able to figure out where the numbers go for each of these. So that means the only places we don't have numbers currently in this equation are with the grams. So the first one is going to be whatever we start with. And the other ones are going to be the molar masses. So this one is the molar mass of N2, which is, I wrote it up here already for you, 28.02. And this one is going to be the molar mass of hydrogen, which is 2.02. And then you're just going to have to multiply everything on top, divide everything on bottom. So I hope this was helpful for you figuring out where to put your units and then where to put your numbers and kind of summarize all the information. One other thing before I end this video is one common mistake I've seen with calculating molar mass is sometimes people have been using the coefficients in front in your calculation. So your molar mass is specific to each molecule. So nitrogen has a specific molar mass, hydrogen, water, any sort of molecule has a molar mass. But we don't really care about the coefficient in front. This is like our recipe and telling us how many of that thing to use. We just want to know the molar mass of one of those, because where we take these coefficients into account is when we are using our mole ratio. So you don't want to include it in your molar mass because that would be using that ratio twice and it would throw your numbers off. So if you're looking for the molar mass of hydrogen here, you're going to want to find on your periodic table the mass of hydrogen, which is 1.01, and there's 2 hydrogens because of the subscripts. You always count subscripts for molar mass. And let me write that to this side. So we will use our subscript, so we are going to have 2 times our 1.01, giving us 2.02. But we don't ever use our coefficients. So this 3 in front of here, it's telling us that 3 moles of H2 and 1 mole of N2 will make 2 moles of NH3, but that doesn't have anything to do with our molar mass itself, so we can just ignore that and we will use that number later in our equation. So that's another thing that I've noticed, is that sometimes people have been using that number, but we don't need that number at all. So like in NH, if we're trying to calculate the molar mass for NH3, we would add 1 nitrogen and 3 hydrogens together to figure out the molar mass, and you would ignore this 2 in front for your molar mass calculation. So I hope this was helpful in learning about stoichiometry.